when I was 3, and it wasn't. I didn't try to keep it a secret for him, and I knew that nobody was going to save me, so I had to save myself.
What's up, Rob?
Hey, Debbie. You see and hear us okay?
We can, but I see split screen on there.
Yeah, I'll take care of that. Sorry. They still
Okay,
have
that's fine.
issue
That's
on
fine.
the Hey, Debbie.
Hey.
Is that better?
Yeah, that's good. Thank you.
All right. Thank you for telling me.
So the first thing tonight is I went backwards to pick some homework problems out. I mean, I know you've already been tested, but I haven't seen any of your work. So, like I said, I went backwards and I picked, I wasn't going to pick a bunch of them. So for homework 4, that'll be for Tuesday, the 5th of March. So I picked one problem out of chapter 4. What you're going to need here is you're going to need a scatter plot. And you're going to need to calculate R. I'll show you that in a minute, just to remind you. And then out of chapter 5, remember 4 and 5 went together. Out of chapter 5, I picked this problem 5.32. And the thing is, when you look at it in your textbook, and I'm on page 155, you don't need to do the mini tab because they've actually taken the mini tab and printed it out for you and put you what you needed to see right there, right? So you don't have to do it. So you just answer the questions based off of that output there. And then out of chapter 6, I picked 621. Remember, chapter 6 is about the two-way tables. 6.21 is you got a two-way table, and I'm asking you a couple like little conditional percentages. And then the one where we have to do something out of chapter 6 is 6.31. And what you're going to need here is, I'll read that to you in a second, you're going to need 2 conditional distributions. Remember, conditional distributions are where you fix the rows or you fix the columns. You're going to need 2 conditional distributions of health given, and I'm going to write it like this, smoker. And what they ask is the person a current smoker, yes or no? So that's what I mean by that. So you'll have one conditional distribution of health for the current smokers, and you'll have one for the health for the not current smokers. And then I would like to see a cluster bar graph. So what do I got here? 4 problems. The only reason I picked 4 is because we were backing up here. All right? So this 429 out of chapter 4, all right, it says this. It's about the sparrowhawk colonies. Me and you did a problem about sparrowhawk colonies in chapter 5. This is the one that was before there. And what they want you to do is, they give me the data, right? They got the percent returning, got the number of new adults that joined, all right? It says, plot the count of new adults, the response variable against the percent of returning birds, explanatory. So remember, in Minitab, when I go to find this file here, and the file is for problem 429, and it's titled Sparrowhawk. This is what it'll look like. Right, so I had 13 colonies. For each one of the colonies, I had the percent that returned the next year, and I had the number of new birds that joined. If you want to make a scatter plot, it's the one right at the top under graph. I just want a simple one. I don't want anything fancy here. And remember, it says the response variable, it's telling me the response variable is going to be the number of new adults, and the explanatory variable is going to be the returning birds, percent returning, so new birds is Y, percent returning. This is the scatter plot that I'm expecting to see out of you folks. And then it wants to know, based off what you're seeing, describe the direction and form. The direction is, do you see a negative association or a positive one? And then it says, what's the form? Well, we only have one favorite form, right? We're always interested in linear. And it says, is the correlation R an appropriate measure of the strength of this relationship? I'm going to tell you, I do believe it is because things are looking rather linear here. Not perfect, but things are looking linear. Calculate R. Where did I do that at? Stat, basic statistics, the 5th one from the bottom, correlation. Put both of your variables in there. The correlation is minus 0.748. So yeah, what? I'm seeing something negative, and it's looking like it's pretty linear, right? We're looking moderately strong here. That's what it's asking. And then you read part B because it's asking about, depending on whether it's negative or positive, it tells you something about the type of bird you're looking at, territorial or what is it, territorial or long-lived territorial birds or short-lived birds. You decide on what the sparrow hawk is. Like I said, the problem out of Chapter 5, you don't have to do any of the mini-tab. The printout's right here on page 155. I think it's figure 511. It tells you everything you need to know. And hell, they did use mini-tab to give us the printout, so it's there for you. And then out of Chapter 6, 621 is based off the two-way table, and the two-way table is at the bottom of the page 174. And then this 631 here on page 176. It says, University of Michigan Health and Retirement Study, HRS surveys, surveys more than 22,000 Americans over the age of 50 every 2 years. A subsample of the HRS participated in a 2009 internet-based survey that collected information on a number of topical areas, including health, physical and mental health behavior, psychosocial items, economics, income, assets, expectations, consumption, and retirement. Two of the questions asked were, would you say your health is excellent, very good, good, fair, or poor? Remember, these people are over 50, so that seems like a reasonable question. Do you smoke cigarettes now? So in other words, there are two categorical variables, and I'm looking at this two-way table just to refresh your mind. The row variable is how they felt about their health, and the possible choices are excellent, very good, good, fair, or poor. And then the column variable is, are you a current smoker, yes or no? The thing about this table is they didn't sum anything up for us. They just gave me the counts as they came to you, classified by current smoker, yes or no, and your health. What do the data say about differences in self-evaluation of health for current smokers and non-smokers? So when I say you want two conditional distributions, I'm expecting you to calculate these by hand. I want the conditional distribution of a person's health, given that they say, yes, they are a current smoker. So in other words, we're only going to look at the first column there. And then I want to see the conditional distribution of health, given that the person is not a current smoker. I'm going to look at the second column and only do everything out of there, right? In other words, when you do these, one of the totals is going to be the first column total. In other words, the number in the denominator for the others. And then the other is going to be the second column total that you have to do by hand. And then it says, what do the data say? Well, I don't always just want to look at numbers. So what I want is, I want this cluster bar graph. And I'm in chapter 6, 31. All right? Now, how did I make that cluster bar graph? I went to graph, bar chart. Remember, everything for us, the whole semester up until the end is summarized values from a table, and I want cluster. Because I like that one the best. If you want to do the stacked one, segmented one, you can do that. And it wants to know where's the actual count. That's the graph variable. Now, I'm expecting to see two conditional distributions. One for the, given that the non-smoker, current smoker, yes, current smoker, no. So whatever variable I put in here first, that's going to be the given that part, as I've said before. So I'm going to put smoke and then health. I want to go to chart options. I want to show the bar heights as a percentage, and I want to show them within categories at level 1. So, I got a conditional distribution for health for each one of the current smokers, yes or no. Right? The one on the left is where the current smoker was yes. The one on the right is the current smoker is no. Okay? All I'm showing you is the two conditional distributions that you calculated for me to start with that I'm asking you to do for me. Right? I want to see you calculate those. And then I have this. Well, so let me ask you this. Is there any difference about how people feel about their health depending on whether they are a current smoker, yes or no? And then what the hell am I asking you when I ask you that? These two look the same? Obviously, how they feel about their health doesn't have anything to do with their current smoking. They're not going to be exactly the same. What about if I looked at this and told you this? Look at the ones that are not current smokers. Look at the ones that said excellent, very good, And then look at the ones that said fair or poor that are current smokers. When I see this, what I'm thinking is, hey, if you're a current smoker, you don't feel as good about your health as if you are not a current smoker. Yes? So, let me see these. See these? No current smoker. There's a high percentage in those two that said excellent, very good, correct? See these? The reason I'm singling those out, the ones that said good is about the same. That's where the difference is at. See, if you're a current smoker, you don't feel as good about your health as the not current smoker. Right? Because why? There's a higher percentage that said no current smoking that say excellent or very good compared to the ones that are current smokers. And if you like, there's more that said fair or poor in the current smokers than said so in the not current smokers. That's the reason I color coded it like this. I'm looking at the two that's red, and I'm looking at the two that's blue. So it looks to me like, based off the data we're looking at here from this table and from my cluster bar graphs, it looks to me like, yeah, if I'm not a current smoker, I feel better about my health than if I am a current smoker. So I answered that one for you. So what I would appreciate out of you is that you should calculate the two conditional distributions by hand, and then give me this bar graph, and then tell me what you see in it. In other words, does it make a difference whether the person is a current smoker or not on how they feel about their health? And you've got to tell me yes, because yes it does, and then tell me how. Okay? And that should take care of everything we need to be able to calculate here with me. Did I really only pick 3 problems? 4. That's unusual for me. Now, where we are at in our textbook and what we were talking about on Tuesday is we were in Chapter 8, and what I got on my mind about Chapter 8 was, I'm going to remind you the title here. It is producing data. Sampling. And where I left off is I was looking at good sampling designs, right? One that used chance. And I'm going to start numbering again for you. Good sampling design. Another way to think about good is these are not biased. They don't systematically favor certain outcomes. What's the first one? I'm just going to write it like this. Remember, simple random sample, that's the one I used, table B. We actually chose a simple random sample by hand. Right? That's like, what, names in a hat. 2 is the stratified random sample. Remember, that's the one where we take the population, and before we do anything, we start dividing the population up into similar groups like males and females. What else did I use? If you were registered voters, whether you was urban, suburbs, or rural. What else did I break up? I think I actually broke you guys up as ETSU undergraduates as freshmen, sophomores, juniors, and seniors. The catch is, you know it's stratified because the population is divided up into these groups. And then what do? You sample within each group. You take an SRS within each group, and you put them all together here at the end to get your full sample. The third one, that's not in your textbook, but it's in the textbook, but it's not in the chapter, it's in the homework, was a systematic random sample. I told you to take a look at a particular problem, and I gave it to you like this. I was thinking about doing quality control. We're making some product that we're going to sell to the public. And so what we do is, every morning the guy that's in charge, he comes in and he's got like, what I tell you, like little marbles on his desk. It's got numbers, maybe the number's like 10 through 20, and he picks one out. Okay, so this morning the dude picked 11 out. And so what's he going to do? He's going to choose every 11th one off this assembly line. 11, 22, 33, 44, 55, that will be his sample that he does his quality control. As long as that number that you start with has been randomly chosen, then we just pick that number down the road. Right? That's systematic random sample. And I do want to circle something here. All three of these. Look at the word random. See, they're trying to tell you, we're using chance to choose your sample. We like that. We want to hear that we have some version of a random sample. The fourth one is, this is the one I left you with, is a multi-stage sample. Unfortunately, there's no random word in there, but it's still going to be random. And here's the way this works. You choose the sample in stages, or if you like, I'm going to use stages, but I could have said steps. You know, we didn't do any of that with simple random sample, stratified, or systematic. It's like, okay, here's what you do. You get your sample. But here we're going to do it like a funnel. And so here's what I want to do. Normally, like national surveys across the United States are this idea of multi-stage. So I want to do this. Just for the sake of things, let's say I'm going to choose, this is what I want in the end. This is what I want my sample to be made up out of. I want 10,000 households. So here's my problem. If I do a simple random sample, right, and I choose 10,000 households in the United States, is it possible I got to send people to all 50 states? Oh, shit, yeah, that's a problem, right? So we want to kind of get away from having to go everywhere. We want to go to certain areas. So what we want to do is, and I mean, I don't know how many steps you want me to do to get this thought ahead to you, but the first one is, we want to choose a stratified random sample. I'm going to do it like this. Now, you see this? If it's stratified, I got to tell you how I took the 50 states and how I divided them up. Well, I'm going to make it real simple just so that we can do this. I'm going to do the East, the South, Midwest, and West. So I'm going to choose 2 there, 2 there, 2 there. That will give me my 8 states. So somehow I'm going to divide my 50 states up into 4 regions, right? 4 strata, 4 groups. The East, the South, the Midwest, and the West. For some reason, I got like NCAA bracket on my mind. I apologize. Basketball popped in there. Okay? Now, the next step. Is it possible in each one of my states, let's say, to get the list of cities in each state? Sure. See, here's where I think of a funnel. So the second step is going to be, okay, is to choose an SRS of now I got to add something to this. I want to choose 100 cities within the 8 states from stage 1. So here's what I've got. I've got my 50 states, and I've chosen 8 of them. Within those 8, I'm going to choose 100 cities. Okay, within those 100 cities, you think I can get a list of all the households? Yeah. So I'm going to shortcut this and say, look, I'd just like to choose an SRS of 1,000. What I want, 10,000? 10,000 households. Within the 100 cities. So I did it in 3 steps. So I started out with, all my households in the 50 states. I chose 8 states. Within those 8 states, I chose 100 cities. Within those 100 cities, I chose those 10,000 households. So what's the worst thing that happens? I got to send people to 8 states, right? Well, how do I know that? Because I'm down to 8 states, the first step. And then within those 8 states, I can send people in one state to more than one city to, I don't need as much people, I don't need as much time, I don't need as much money. I funnel all households down to ones that were in 8 states, down to the ones in the 100 cities there, and then my 10,000 households. Right? So you funnel down. Let me ask you this. Is this a probability sample? Remember, I talked about probability sample gives every individual in the population a no and non-zero chance of being selected. Does this give every household a chance of being selected? Every household's in, I'm going to say, in some city or some place like that, right? Every city is in some state, so everybody's got a shot. Okay? This is a probability sample. Now, here's my thing with this. Before I go on to how else can I screw up a sample, there's 4 good sampling designs that we like. Simple random sample, stratified random sample, systematic random sample, and multi-stage. All 4 of these use chance. All 4 of these are probability samples. All 4 of those are good sampling designs. We trust the data that come from these 4 types. To be honest with you, after this chapter, the one me and you always talk about is that. An SRS is the building block. That's the most basic. All the things we're going to do the rest of the semester, we're always worried about that we have a simple random sample. We just work off of that building block. We don't go anything more elaborate than that. I just wanted you to know there are other ones out there that are using, let's say, like a simple random sample within them that people talk about. Stratified, systematic, multi-stage. What's so good about my 4 good sampling designs? They eliminate bias, which is what we're trying to do. Now, the only thing that's left here in this chapter is we know we're going to use one of the good 4 sampling designs to choose our sample. The problem is, okay, we know we're going to do one of the good ones. Can I still screw stuff up? In other words, can I still have some bias in my data, what I'm looking at? And so, I've got 4 of these. One of these is called under coverage. Okay? Now, I need to give you a definition. Alright? Before I talk about this, I need something called the sampling frame. So anytime somebody's going to choose I'm just going to say a random sample, one of our good ones, you need something called the sampling frame. And the sampling frame, all that is, the list of the individuals, in the population, that is used to choose the sample. So I don't care which good sampling design you're using. At some point, you've got to have a list in the population in your hand so that you can randomly choose from that list, right? That list that you have in your hand, whatever the list is, that's called the sampling frame. Now, where people get into trouble is, when you look at your sampling frame, there are people missing in the population that's not on your list. I'm going to give you something very, very simple and something you can remember. If we use the phone book as our sampling frame, for example, we use the phone book in Kingsport to start choosing registered voters. Are we missing any people in the population that are not in the phone book? I'm missing a whole shitload of them. Anybody that's got an unlisted number, anybody that's got a cell phone only, anybody that's in jail, right? I'm missing the homeless. Am I leaving out groups of the population? And the answer is yes. So if you use the phone book, your sample is going to suffer from undercoverage. In other words, what this means, incomplete sampling frame. In other words, the list that you have does not include everybody in the population. Now, is it actually easy to come up with a sampling frame that's complete? Oh, no. But we always do the best we can, right? We always want to minimize as much undercoverage as we can. Any other sources of biasing. So that's the way I think about it. Somebody's talking to me about undercoverage. That just means whatever list you had, whatever sampling frame you were using, you left off groups of the population on your sampling frame, right? It's incomplete. That's as simple as I can make this. 2 is non-response. Oh, I can't even give you a definition. That's right. You send a questionnaire to somebody's household. We did everything right. You know, we had a complete sampling frame, so we didn't have any undercoverage. Hell, we choose a stratified random sample. We get a really nice questionnaire and we mail it to the household. And what's the person at the household do? In my household, we use it to start the fire. In some other households, we just like to throw the shit in the garbage, right? You know what that's called? That's non-response. Have you had them? I've had them do this. So they didn't send me the questionnaire in the mail. Hell, they called me on the phone. You know, they did a nice random sample. What time did they call me? They called me at 6 o'clock. I'm getting ready to eat dinner. You want to talk to them now? No, give me your phone number and I'll call your ass back when you're eating dinner and we'll talk then, right? That's non-response. No, when they call, you don't pick up the phone. No, that's a problem. See, what we're worried about is non-response is usually given to everybody as a percentage. You know, we tried to contact 10,000, but we were missing 1,000 that didn't respond, so that's what, 10% non-response, yes? Well, why is that a problem? Let's say, like, you'll see some things where non-response gets up to be like 30%, 40%. Is that enough to change your results? In other words, flip it the other way, and the answer is damn straight. Is that the same problem back here? You're leaving out groups of the population. You don't even have any opinions from those groups. Is that enough to like change what people are thinking when your data? Exactly. Look, both of these two here are such a big deal. Undercoverage and non-response. Our federal government's got a problem with this. Remember we talked about the census the other day? Remember that's where you try to collect information on everybody in the population? You know they do a current population census, right? Every, 2 years or something like that? Do you understand they suffer from undercoverage? When they're trying to collect information on every household, you know there's households they don't know about, the homeless people, all that kind of stuff. They suffer from non-response too. I didn't realize that it was such a big deal until I taught the class. You know, they used to send that stuff in the mail, right? And I used it to start the fire. It turns out they'll send it to you a couple times. Then, when you start the fire with it all the time, they send somebody to the house. Turns out it's against the law to start the fire with their population survey. Just a thought. The point is, you understand our federal government has all kinds of manpower and all kinds of money, our money, to spend on things like this, and they still have a problem with undercoverage and non-response. Right? 3 I'm guilty of. Now, I do have a little thought about response bias. And what we mean is not truthful and I'm going to give this to you in two ways, and I'm guilty of both of them these days. What I mean by response bias is if you want me to start telling you something that's not true, start asking about something illegal. Like, for example, Mr. Marks, did you wear your seatbelt when you drove to school today? Well, of course I did. That would be response bias because you're not telling the truth, yes? And the other thing I'm guilty of is, okay, Mr. Marks, how many movies have you watched in the last year? I can't remember what happened yesterday. Well, I mean, I give you a shot. Hell, I probably watched 10. Am I correct? I don't know, because you're asking something about the past, right? And a lot of people just can't remember. Are we trying to give you not truthful answers? No. But we are because we just can't remember. You understand? That's biased, right? Because, I'm guessing to tell you how many movies. Or if you start asking about something illegal, shit, I'm going to tell you exactly what you want to hear. All right? That's response bias. 4, and you would never think 4 would be a problem. I can see 3 being a problem. Don't start asking people about illegal, and don't start asking older folks about what happened a year ago or in the past year. The 4th one is somebody usually has a purpose when they do this. It turns out the wording of the questions can have an influence on how people answer them. I got a couple of thoughts about this. Sometimes the questions are worded so poorly, so confusing, that people know they want to answer yes, but the way you word the question is my yes or no, is my yes or yes, is my no. They don't know, right? The other thing is, have you ever seen the questions where they lead you? You have, you just haven't paid any attention to them. Given the fact that plastic disposable diapers make up 75% of the trash in landfills and will be there for the next billion years, how do you feel about using disposable diapers with your baby? I don't feel good. I don't want to kill the planet. They're leading you right to the answer. It turns out another way is, now we all know there's something called welfare, and then there's assistance to the poor. It turns out the general population, they don't like welfare, but they'll support assistance to the poor. I mean, hell, I'm only changing 1 or 2 words there, and I'll get you different responses. If anybody took the class survey, anybody take the class survey yet? I know some of you did. Did you notice, like, the questions are just, like, freaking to the point, right? There's no wording, there's nothing wording, there's no misleading. It's because the statistician wrote it. We're not trying to bias our results with the wording of the question. So here's my thought. These 4 things are bad. These are other sources of bias, even though that we've got a good sample. We did a random sample. If you've got undercoverage, you got a problem. You got non-response, especially when non-response starts getting up at like 30% or 40%. That's enough to change anything. I thought I get those people to answer. Response bias. Be aware of that when you're asking people about seatbelt use, illegal drug use, right? Or if you're asking people about something in the past. And then we always want to read the wording of the question. So here's my final summary for this chapter. You cannot trust the results of a sample survey, which is what we've been talking about all along here, until you know the following. 1, we always want to know the questions asked. I don't want to know the thoughts you were asking. I want to know the actual questions that you asked the folks. What am I looking for? I'm looking for confusing, leading, all that kind of stuff, right? I'm looking to see what the question was. 2, I always want to know how the sample was chosen. Why do I care about that? What am I looking for here? I got to change color. What I'm looking for is, I'm not expecting when I read somewhere that somebody's going to tell me they did a simple random sample, stratified, multi-stage. What I'm expecting to see is somebody tells me they're random. What do I not want to see? I don't want to see a convenience sampling. I don't want to see voluntary response, self-selected. I know those are problems. 3, I would like to know the amount of non-response. I would like to kind of know it, if I could force them, in terms of a percentage. Because every sample survey is going to have some non-response, 5, 10%. But if I get up to 40 or 50%, folks, you got too much non-response. That's enough to change what my results are here. And then, look, all these we've talked about already. I got a 4th one, new one. The date of the survey. What do I want? I want current data. In other words, if I'm trying to draw a conclusion about, well, hell, just think about the president's approval rating, registered voters. Now, you got to understand, I don't know if you follow what goes on in the country all the time, but I want data like from the last week, right? Because that's current. I don't want anything from like 6 months ago. They thought a whole lot different 6 months ago than they do today. So I want something that's current. And sometimes you'll see people like they're talking about an issue today and they're giving you data from 10 years ago. What? No way. You want current data. That's as simple as I can make this. All right? To me, that's what's in this chapter. That's all. And when I say that's all, was there really that much? And the truth is, no, I talked about it a lot. See, I got 2 hands. Simple random sample, stratified, systematic, multi-stage. We like these. Convenience sampling, voluntary response, self-selected, bias. My sources of bias: undercoverage, incomplete sampling frame, non-response, people just won't respond, response bias, people answers, wording of the questions, hell, the questions are all screwed up. I can't tell what you're trying to ask me, they're confusing, or you're leading me towards an answer. Not good. We went to the point and short. I probably should have said something about the length of the survey. You notice the class survey was what, 15 questions? Yeah, see, you stayed interested for 15 questions. Could you imagine if it was 30? Yeah, that was the look I had. You give me that little, what the hell? Yeah, I get to like 15, 16 questions. I'm going, shit, you want me to answer 14 more? I'll just answer anything. Yeah. Right? So, we try to follow our rules that we're talking about. The length makes a difference. I always told them 15 was too many. I'm like, can't you do this in like 10? I can keep their interest for 10 questions. That's usually the way it works. Are we okay? So, now we go to chapter 9, which is another way of producing data. And chapter 9 will be a little more involved than what we did in chapter 8. Always whenever we talk, I always have definitions and everything like that. Chapter 9 here is producing data, except this time, not sample surveys. This time it is experiments. Now, I'm going to circle this. I've used that word on you before. I used it on you at the end of chapter 5. When we're looking at, cautions about correlation and least squares regression lines, and we were talking about causation. Remember this idea of cause and effect? If I make changes in one of your variables, will it cause a change in the other variable? And I told you the best way to find evidence of changes in this one will cause a change in this one is through, I probably said well-designed experiment back there, right? It's an experiment, okay? So, here's where we're at. To start with, there's two things. There's something called observation versus experiment. Not the same thing. Okay? So what we think about is something called an observational study. So what we do here is you observe the individual, and measure variables. It might be just variable of interest. In other words, whatever you're interested in, you just ask them the question and you get your answer. The point is, we don't try to influence the, I'm going to say, response to whatever the question is. Right? We're just trying to measure whatever variables. It's almost like where I started chapter 9 is, I want to know about college students, right? I just want to know the answer to the question. I don't want to try to influence it at all. I'm just observing them and measuring whatever the variable of interest is. Now, one type of observational study is what we have been looking at. Those are samples. If you like those sample surveys we just got done talking about, those are observational studies. Right? We're not trying to influence the response. We're just we want the response. Now, what makes an experiment an experiment? What separates an experiment from an observational study? Well, an experiment I'm going to make it as simple as possible. What we're going to do here is you're going to impose a condition on the individual to measure the change. And I'm going to do this condition, we're talking about, when we speak of an experiment, we're talking about some kind of treatment. We impose a condition, we impose a treatment on the individuals to measure to see if we've made any change in them. All right? Now, my two definitions that I just gave you, the way I think about these are on the top of page 230. I'm going to read them to you. Again, I wrote them, you wrote them, here they are. It says, an observational study observes individuals and measures variables of interest, but does not intend to influence the response. The purpose of an observational study is to describe some group or situation. It's to collect data, right? We're not looking for cause and effect. It's just to describe, what do college students think about people obeying laws that violate their personal beliefs? We're looking at these sample surveys there. Then an experiment, on the other hand, is just the complete opposite of this. Deliberately imposes some treatment on individuals to observe their response. We're going to measure the change. An experiment is all about I'm going to keep throwing that word out there, and when you see me write that, I'm thinking cause and effect. I'm going to make it very simple for you. If I make changes in my explanatory variable, will that cause, will that have an effect on my response variable? Can I change your blood alcohol level by changing the number of beers you drink. And the answer to that question is that's causation, that's cause and effect. We need an experiment there. All right? Now, example 9.1, if you don't mind. It says, does playing video games improve surgical skills? Because the reason I'm going to read this one to you all the way through, if I can get you to understand the difference between, okay, this is an observational study, and how I would do an experiment, the rest of the chapter is just about an experiment having its own language. If I can get you to understand the thought process of what distinguishes observational study from experiment, we're good to go. All right? So, it says, in laparoscopic surgery, a video camera and several thin measurements are inserted into the patient's abdominal cavity. The surgeon uses the image from the video camera positioned inside the patient's body to perform the procedure, manipulating the instruments that have been inserted. The dude's playing a video game while he's operating on you. He's watching the TV, right? That's what they're trying to tell you. Because of the similarity in many of the skills involved in video games and laparoscopic surgery, it's hypothesized that surgeons with greater prior video game experience might acquire the skills required to in laparoscopic surgery more easily. In other words, if you're good at video games, maybe you'll be good at this kind of surgery where you insert the instruments and I'm watching the TV screen. Okay? It says 33 surgeons participated in a study. Now, just because somebody's using the term study on you, some people use the term study and they're still doing an experiment. All right? It says we're classified into 3 categories: never used, under 3 hours per day, more than 3 hours per day, depending on the number of hours they play video games at the height of the video game use. So you've got 3 groups here, right? Never played, less than 3 hours, and more than 3 hours. So I got these 3 groups here. All right? It says it was found that those with more video game playing did better in the simulator program measuring laparoscopic skills. However, so here's the thing. They checked this out, right? They took these 33 surgeons, they divided them up into 3 groups: never played, less than 3 hours per day, more than 3 hours per day. And what they found was that those with more video game playing did better in simulator program measuring laparoscopic skills. So my question to you is, does that mean that the ones that have more video gaming, that caused that? No, what I'm asking you is what I have read right here. Is that causing this causation? Is it causing them to be better at the laparoscopic skills? It says, however, in their conclusions, the authors correctly pointed out that this is a correlational observational study, and therefore causality cannot be definitely determined. Translation? That's an observational study. How do I know? Did they impose a treatment? No. The surgeons got to choose how much video games they played. They never played. They played less than 3 hours per day, more than 3 hours. It turns out in the end that the ones that had more video game experience did better in the simulator. But does that mean that the video game caused it? And the answer is no, because it's an observational study. Nobody imposed a treatment here. One more time. Observational study, no treatment was imposed. Now, although the data showed a clear association between your laparoscopic skills and the amount of video games you played, between prior video game experience and your improved scores in the simulator, we cannot conclude that more video game playing caused the improvement. Okay, you're going to see my left hand go up, and they're going to start reading things to me, and I'm going to start numbering them for you. It says, people who play more video games may be different from those who don't, in terms of both their interests and the nature of skills that are required in video games. Those who play more video games may have scored better simply because they have a better ability in such areas as fine motor skill, hand coordination, depth perception that are required in laparoscopic surgery. What are these 3 things here? That's chapter 6 also. That's chapter 5. No, what was it called? They weren't measured, were they? They weren't part of the study, but are they there? Those are working variables. See, here's the problem. That's an observational study. When you have an observational study, I don't know if it's actually the variable you're looking at, the amount of video game playing they did, or if it's some other lurking variable that's causing the effect you're seeing, or a combination of all of them. Before I get to read you the last paragraph, I got to give you this little thought. observational studies, where we're supposed to observe and measure variables and not impose a treatment, observational studies always suffer from, the term is confounding. Confounding means you cannot tell me which variable is causing the results you are seeing. I don't know if it's the video game playing experience. I don't know if it's their fine motor skills or hand-eye coordination or depth perception. I don't know what the hell is causing it. Why? Because it was an observational study and the variables are confounded. You cannot distinguish what's causing the effect that you are seeing. So observational studies will always suffer from confounding, and I should add to this, when we are looking for causation. Anytime I'm looking for cause and effect, an observational study will always suffer from confounding. I don't know if it's the variable you were interested to see if it was causing a change, or if it's one of the lurking variables you didn't even pay any attention to, right? So you can't prove cause and effect, causation, from observational studies because of what I got underlined there in blue. So how do we fix this? I'm not even going to read the rest of this. How would I turn this into a well-designed experiment very, very simply so that I could actually look for evidence of cause and effect? So what I got to do is this. I got to find me 33, I'm just going to say 33. I need to find 33 people that I want to try this out. Right? They don't have to be certain. And I'm going to assume that I don't really care what kind of video game experience they had, but I want to divide them up into 3 groups. How am I going to do that? I'm going to label them from 0, 1 to 33. And I'm going to choose an SRS of 11 of them for this one, another 11 for this one, and whatever's left is here. Right? So here's my question. Are all 3 of these groups the same? In other words, will there be people in all 3 of these that have good hand-eye coordination, good fine motor skills, good depth perception? In other words, are the lurking variables in all of these groups? And the answer is yeah. And so now to impose the treatment, we're going to have these people not play any video games. We're going to do this for maybe 6 months. Never play a video game for 6 months. These are going to play less than 3 hours a day. These are going to play more than 3 hours a day. Am I imposing a treatment? Did they get to choose how much they played? No. I chose for them, right? None, less than 3, more than 3. So after 6 months, and I put them back in the simulator, just for the sake of things, say this group does better. What caused it? It had to be the video game. How do I know that? What's the only difference between my 3 groups here? No video games, less than 3, more than 3. The lurking variables a problem? No. They're spread out across all of them, right? You'll have each type of people in all the groups. The only difference between the 3 groups is the actual treatment. So what would have caused that big jump in that group? It had to be the actual treatment. That's an experiment without all the fancy language, without all the fancy words. That's the deal. Experiments do not suffer from confounding because we take care of that. Now, on page 232, we got to get our language right about experiments, our vocabulary, and we're going to talk about subjects, factors, levels, and treatment. I always add that one in. Okay, so when you're speaking of an experiment where you're going to impose a treatment, the subjects are the individuals, that are having the specified condition or the treatment imposed upon them. The subjects can be people, they can be cars, they can be dogs, they can be cats, they can be mice. It's whatever is being experimented on. You'll hear me talk about subjects if they're people. I may even say the term experimental units. All right, so that's the subjects, that's the individuals. Those are the objects that are having the treatments imposed. Now, unfortunately, with an experiment, the factor or the factors yeah, we can't call them explanatory variables. We have to call them factors. What are the factors? No, this is explanatory variables mean you've been talking about since chapter 4. Okay? And then, when I think of levels, and this is not in the little box here on page 232, the levels, different, I'm just going to say it like this, values of the explanatory variable, or of the factors, however. I need to use that term. For example, back to my little video game, right? The explanatory variable there is the video game, right? Playing video games. What was the different levels? None, less than 3 hours per day, more than 3 hours per day. So I took my one factor, playing video games, with its 3 levels, and I end up with 3 treatments. The treatments are nothing more than the specific condition imposed. That's all. So before we can go further and start like saying, okay, how do I set one of these up? We need to make sure that we can identify, okay, somebody gives me a setup of an experiment, and we identify the subjects, the factors, the levels, and the treatment. All right? So I'm looking at this example 9.2, and I'm actually going to look at, I'm probably just going to look at example 9.2. Okay? It says this, foster care versus orphanage. Do abandoned children placed in foster homes do better than similar children placed in an institution? The Bucharest Early Intervention Project found the answer is a clear yes. The subjects were 136 young children abandoned at birth and living in orphanages. So here my subjects are what? 136 young children. I'm just going to give you 136 children. Obviously, there's a little more to this, right? They were abandoned and living in orphanages in Bucharest, Romania. Half of the children, chosen at random. How would you do that? I just want to keep that stuff in your head. I would label the children 001 through 136, right? And I would choose a simple random sample of half, 68. So I'd go through and I'd read table A, pick a line, and I'd read them as triples, and I'd pick out the first 68 triples that I have as the label 001 through 136, and I would take those. So I'd have 68 in this group, 68 in this group. Were they randomly selected? Should my groups be similar? Okay. Half of the children chosen at random were placed in foster homes. The other half remained in the orphanage. You understand, where was this done? Do you think this kind of experiment would ever be done in the United States? Oh, dear God, no. This is Bucharest, Romania. Get away with anything there. Okay? Now, it says, the experiment compared these 2 treatments. There is a single factor. So my factor here, in other words, what am I changing is the way to think about it. The factor is the type of care. Now, the type of care came in 2 different types, right? 2 different levels. And so my levels here are what? Foster home, foster care, or institutional care. Orphanage. Now I'm going to label these. There's 1, there's 2. All right? There's 2 levels of the type of care. There's 2 different versions of the type of care. And so what's my treatments here? And how many treatments should I have? I'm going to have 2 treatments. Well, that's my 2 treatments. The reason this is so straightforward here, I'm thinking it's straightforward because you have a single factor that has 2 levels. 1 factor, 2 levels is going to equal 2 treatments, right? 1 times 2. 1 factor, 2 levels. Suppose there had been 3 levels, right? Foster care, institutional care, and some other kind of care. How many treatments would you have had? Right? 1 factor, look at it this way. If you have a single factor that you're changing the value of, in other words, here, when I say changing the value of type of care, you're giving different types. The levels are telling you the treatments. Right? So that's how I'm coming up with my 2 treatments. And then something we haven't mentioned here is, well, I have to measure something after the fact here, right? After the experiment is done, I need to measure something, and it is the same term me and you have used before. The response variable is what you measure after the treatment has been imposed. And here, the response variable, they're going to tell me, the response variable included measures of, they don't tell me exactly, but it's measures of mental and physical development. However they did that, a test or whatever. But that's what they measured after the fact. And so what are we looking at? I'm just going to add a little bit to this. Because, look, all this problem did here was, can we pick out the subjects? Can we pick out the factor or factors? Can we pick out the levels? Can you tell me what the treatments are? Can you tell me what you measured after the fact? Right? So in other words, what are they really wanting to do at the end here? They're wanting to compare these measures of mental and physical development for the 2 treatments, right? To see if one treatment was better than the other. Right? Living in foster care, was that better than institutional care? Hell, was institutional care better than foster care? Or was there no difference? Okay? Now, I'm going to skip over 9.3. You can take a look at that at the house. Here's the thing. Advantages of an experiment. And it's an advantage over an observational study. I got 3 of them. All right? The first one is you avoid confounding. Why? The individuals don't get to pick their treatment. We pick that for them, right? We assign subjects. And what do I mean assign? Assign subjects to what? We assign subjects to treatments. They don't pick, we pick for them. We do it in a nice random fashion. 2, we also, with an experiment, can control the environment. Of the subjects. Okay, so these 2 together. We avoid compounding because we assign the subject to the treatment, and we control everything else about it. Why am I so particular about all this? Because what I want to make sure is, when I form these groups here, and I start imposing my treatment, the only difference between that group, that group, that group, however many groups I have, depending on how many treatments I have, is the actual treatment. I don't want anything in the environment to be different for this group or this group. I want the actual treatments to be the only difference from one treatment group to the next. That's the only way we're going to find cause and effect and not have a problem with See, the environment's a lurking variable too. You know, if this group is treated different than this group, right, that's a lurking variable. So if that group does better, what was it? Was it the actual treatment or was it the lurking variable? We don't know. So we control everything else. 3, we can study the effects of several factors. That's your example 9.3 that you're going to take a little video. So I don't have to have a single factor. Hell, I can have 2 factors. And what I would like is all possible combinations of the different levels of the 2 factors. Look, let's do this. Just for the sake of things. Suppose I have 2 factors. Whatever they are. And so factor 1 has 2 levels. In other words, 2 different values we're going to work at. And factor 2 has right, so I've got these 2 explanatory variables, these 2 factors, and I got one of them has 2 different levels I want to test at, and the other one has 3 different levels I want to test at, and I want to look at all possible combinations of the levels of these 2 factors. How many treatments do I need to have? You're going to need 6. I want this factor with 2 levels, and this factor with 3. I want all combinations of these 2 with these 3. 2 times 3 will give me my 6 treatments. See, back here, I don't have to think too hard. I have a single factor. It's got 2 levels. I end up with 2 treatments, right? But if I have something where there are 2 factors you want to take into consideration, and one has 2 levels, and the other one has 3. I want all these 2 with all these 3. I want this one with these 3, and I want this one with those 3. That's going to give me 2 times 3 or 6 treatments. Okay? Now, the book's going to do the stupid thing to you again, like I did to you in the previous chapter. You're going to call it stupid? Yeah. If you remember in the previous chapter, what did they do to me? They showed me how to sample badly. Convenient sampling, voluntary response, self-selected. Well, how are we going to start here? Showing you what the hell not to do. How to experiment badly. We don't want to do this. And then we'll show you how to do this the right way. So remember, I'm going to write it in red again. I'm thinking of that's what I'm always looking for here. The only reason for me and you to do an experiment is to look for causation, cause, and effect. There's changes in one of the variables have an effect on the other variable. Okay? Now, I'm going to give you a 1 and a 2. 1, we're going to impose treatment. There might be more than one. There better be more than one. And 2, we want to control other influences. That's a nice way for me being me and saying, look, I want to impose these treatments and I want to control everything else. I want to control all the environment. I want to control all the lurking variables. I want to control everything. Okay? The reason for this is because what I want is the only difference between treatment groups, right? You know, we've divided them up, are the treatments everything else about them is exactly the same. And I want to keep throwing this word out here, because you're going to look at some examples, and I'm going to look at examples with you on Tuesday, where it sure of hell looks like somebody did an experiment, but they didn't because, the people chose which treatment they wanted. You never imposed anything. Okay? So, this example 9.4 here is our first go at this idea. And it says this: the college regularly offers a review course to prepare candidates for the Graduate Management Admissions Test, GMAT, business test, which is required by most graduate business schools. This year, it offers only an online version of the course. All right, so they got this GMAT review course, and the catch is it's only online for this semester. All right? It says the average GMAT score of the students in the online course is 10% higher than the long-time average for those who took the classroom review course. Is the online course more effective? This is what I want to know. So they're only offering it online this time. It turns out, being offered online, the students that were in that course did 10% better than the students have done for let's say, the last 10 years. Do you think the online course is better? Let me ask you this. What's the key thing here? Did anybody impose a treatment, or did the people pick it for themselves? The people picked it for themselves. Okay? So the point is, this is a bad design. Yeah, it's a bad design to the point where I have a hard time even spitting out the word experiment here. And what they did was this. I want to draw you an outline of this bad design. In other words, I want to draw you a picture. And what they did is they had their students, right? The subjects here are the students. They had their students. They gave them the online course, the treatment. And then they looked at their GMAT score. I'm going to do it like this. This is the subjects. You gave them a treatment. I'm giving you the general in red. And then you looked at whatever the response variable was. So in this example, the subjects are the students in the class. What was the treatment was actually given? Well, the hell, they took an online course. And what did you measure after they took the online course? You measured their GMAT, right? So what's in red is like the general, where you have some subjects, they take, they have some kind of treatment, and you look at their response variable. Okay, I want to read to you a little more here. It says, this experiment has a very simple design. There it is. I drew it for you in the outline. It says a group of students, the subjects exposed to a treatment online course, so on and so forth. A closer look, now here comes my left hand going to be up, and I'm going to start numbering things for you. A closer look at the GMAT review course showed that the students in the online course were quite different from the students who in past years took the classroom course. Why does my left hand come up as soon as they tell me that they're different than what we saw in the past? What am I getting ready to knock off for you here? I'm going to be ready to tell you about some working variables here. It says, in particular, they were older and more likely to be employed. An online course appeals to these mature people, but we can't compare their performance with that of undergraduates who previously dominated the course. The online course might even be less effective than the classroom version. We don't know. Why? They're lurking variables. These folks were older. I can add some to these. Some of them, they were older. What was it? They were older, more likely to be employed, might be paying for the course by themselves, need it for their job. I'm still working variables here, right? They only gave you the two. I gave you two more. You think that might have a difference with their performance? And I'm thinking, I don't know. I can't tell you if it's the online course or one of these lurking variables I have in my left hand. What's the problem here? Suffers from confounding. I don't know if the online course caused them to do better, or because they were older, because they were employed, they were paying for it, they needed it for their job, and any other thing I can throw out there that makes them different than undergraduate students. You suffer from confounding. I can't tell you what's causing the 10% increase. I don't know, right? And like they said, it may actually be worse if I did a well-designed experiment, okay? Now, I'm going to take the term experiment and I'm going to start adding words in front of it. What me and you are always interested in is a randomized comparative experiments. Now, all I did was just throw two words in front of the term experiment. Randomized. When you see the word random now, what do you think? So we just had this talk in chapter 8. I think you're going to do something in a random fashion, right? You're going to choose something in a random fashion. We're going to use chance. When you see the word comparative, what do you think? Well, when I see the word comparative, I think somewhere along the line we're going to start comparing something, right? Comparative. So, our fix to example 9.3, where there's a problem with confounding, is the comparative part. You always want to, when we think of comparative, I want to compare treatments. Now, I know there's only one that we were interested in, but I still want to come up with another one to have something to compare to. I don't like that simple design. So, what we're going to do is, we're going to have students, and I'm going to do it like this. I'm going to say, one, they're going to be taught let's do it like this. Classroom version of the course or an online version. See, this is what the one you're really interested in, to see if the online version is better. And this one here, I would call it, that's what's been going on for the last 10 years. That's the status quo. That's the norm. This way it's been done in the past. What are we actually looking for? We're looking to see if the online is better than the classroom version. All right? Now, this first one here, this classroom version, the one that's the standard, the norm, status quo, one is called a control group. You know, the status quo, the norm. So that's a definition. You always want to, sometimes we just have a single treatment, so we have to come up with this other treatment that we give to, we're going to call a control group, to have something to compare to, because we always want to do the comparative part. Okay? Now, here's the problem. Comparative is not enough. Comparing treatments is not enough. There has to be the other word that showed up there. We need to randomly assign the subjects to the treatments. That's the randomization part. That's the randomized part. They don't get the pick. We still need that random assignment at the beginning. All right? So these are the randomized comparators. We're going to randomly assign the subjects to the treatment, and we're going to always make sure we have enough treatment so that we can compare. So here's my thought about this. How would I set this one up? And then we'll go to the house. Here's what I want to do. I want to draw you the picture. Some of the homework problems that you're going to do, they're going to ask you about, you would like an outline of this randomized comparative experiment here. Maybe we'll continue this one Tuesday. I got 6:49. I don't want to keep you. You might have somewhere to be at 7 o'clock. So remind me, we were talking about the GMAT scores, online versus the classroom, and I want to draw you the outline of this, where I do a randomized and I do a comparative experiment. All right? Be careful in the house. Don't forget my homework problems. There was only 4, right? Bring those to me on Tuesday.